Hello and welcome with me. It's Amin, and today we'll be learning more on lists, heaps, and decimal precision in Python. So we have a paradigm in programming languages, which is an array. In Python, it's more a list, but here we would have an array where we can embed the same type of inputs inside of this array. For example, a list in Python, we can have different types of variables in here. But if we try to do this in an array, it will raise an error. We have two kinds of errors here. We have the type code, which here should be, for example, let's say h for unsigned int. That's what we have done here. For example, assigned it would look something like this, and an unsigned it would look something like this. And in here, we try to say to this array, we have something like a list, and they say, okay, you know something, we need an integer is required since you say that it's an integer. So here we just say, okay, we'll just put an integer in here, and the array will be fine. It's just a unit-typed data structure that is like the list, but it's not, because as I said, the list can have multiple types of values in it. Here you can check some helping with the array and how it is, and we can slice it just the list, and we can do any other operation like just the list comprehension of Python. Next would be bisect. Bisect would be just to have a list of tuples that are sorted, and we want to insert, for example, something that can be really useful. We want to insert value in these scores with maintaining the sorting. So here with bisect we can do it, and here we insert this value inside of this sorted list. So here we can check with some other ways that we still can maintain the sorting, and we can also insert it. It's not that relevant. Next would be the heap. So what would the heap would be? It's more like let's say the heap, it's a data structure, if you're not familiar with it, that has mainly two, let's say, two priorities. It's a complete binary tree. So here you can see it's just a binary tree. And second, it has two structures. It's either a min heap, if the root node of the heap is the minimum of all the nodes and minimum of its children, or it can be a max heap. And this one, for example, that you see here, it's a max heap where the maximum is in the root node of the structure. And here always the root of each subtree is the maximum of each tree, each subtree, and here it's kind of the same. And this is how we construct this kind of heap. So in computer science, this kind of structure really comes in handy when you want to do some searching algorithms like sorting, heap sorting. So it's coming in hand. And for this heap, it has an array representation. So this is the array representation. This is the first, the root node, and it has two children, and so on and so forth. And in this way, we want to have like a list. In this library, we can use this heap PQ to modelize this and to create these heaps. So we can create a data structure. We have a list of data, and we heapify it, like we transform it to this format, to this array here. We can, and for the heap, we have some kind of operations, like if we want to insert some value in the heap, we will insert it with heap push, because it has to maintain this complete this complete binary tree and the structure, either that in our case, for example, it's max heap. For here, we can check, for example, in data, like let's say just this one, we can check, for example, which is the default heapify or default heapification of our data in Python, and the default. Okay. So the default heapification in let's say heapify is the min structure. So here we can see that heapify makes the min structure. So here we can check how we would do the max heapification, and we can check the help of heapify. And here we have heapify, heap transfer list. So heap in place on in time. Okay. I don't know. Like the okay heap q. Heap, okay, I have to. Heap q. But normally you would definitely find heap push, heapify. Yeah, we have just, it has just normally one, let's say just one one argument functions heapify. Yeah, it has just one argument, which is heap. So normally they don't offer somehow the max hypification in this heap PQ from the Python library. Maybe we can check that out. PQ max heap Python. So from okay, so yeah, we have something like this heapify max. So if you want to have the, let's say the data, this is for example for min heap, and here would be something for max heap, and here we import this heapify max, I guess. Yeah, and here we have the data, and we have the min heap, and here data, we have the max heap, and here we can check it out. So we can, yeah, we have these two structures and we can use them out. And here we have some operations. For example, we can either push this one value with respect to the structure, and we can pop some items from the heapify. And here we pop this the smallest one here. Like here we can fetch the 3 smallest entries, for example. And here we can, for example, in this case here, for example, we can fetch the biggest entries if we do, because it's the max heap. So this is really handy for calculating max, min. It does the calculation in O of 1. Like if you're good with complexity, in O of 1 time, like it will go just to the root node. So if it's a max heap, we go to the root node. It's min heap, we go to the root node, and it's max and min respectively. Last point would be just the decimal floating point, and here we have like more, let's say, more precision. These are the applications for financial applications, control over precision and everything. And you can see that the rounds are quite, if we do just round, for example, of this, With Python, let's say calculation, it will be 73. But if we do it with decimal, it will be 74 because it will really count all the decimals that are between these two, and it will really calculate them. Like that here we can check with the precision. Like if we do something like this, we'll have something like, and it will round it to the plus here. Here we can just check. No, here sometimes like we can really get into a lot of precision. For example, we want precision of 36. It goes like on all of the till the 36, let's say decimal. So it can come really handy when you do some, let's say, some very precise calculations. And yeah, it is also important when you have, for example, this kind of 5, for example, and you want to round the 5. So here on decimal, it will round it to 74 instead of 73. So those are somehow the differences that you would like to use the decimal library. So this is it for this tutorial, and hope to see you for the next and the last one of this series.